Hey there. Today we're going to start our discussion of concentration of chemical mixtures by looking at the relationship between volume and moles. And before we get into looking at solutions and mixtures, I just want to go over the way that we would find the amount of a pure solid or liquid. So if we had a sample of pure solid, for example, a chunk of carbon, the way that we would normally find the amount of carbon, that is to say the number of moles, is we would weigh the chunk, find its mass. In this case, it might be 37.83 grams. And then using the molar mass of carbon, 12.01 grams per mole, we could convert the number of grams into the number of moles. So 37.83 grams, then we multiply by 1 mole is 12.01 grams. Our grams cancel out, and that leaves us with the number of moles of carbon. Now, if we want to find the amount of a pure liquid, we can do much the same thing. For example, if we had a beaker of water. Now, it's not hard to find the mass of a sample of liquid, like water here. We could weigh the beaker with the water in it, and then we could subtract out the weight of the empty beaker. But it's much more common when you're working with liquids, instead of measuring the mass, it's more common to measure the volume using something like a graduated cylinder. And so if you were to do that, and let's say that our sample of water here had a volume of 218 milliliters, if we wanted to use the molar mass to convert, to find the number of moles of water that we've got, we would first need to convert this volume in milliliters into a mass in grams. And we can do this using the density of water. Water has a density of 0.997 grams per milliliter at room temperature. And so if we take our volume, 218 milliliters, and multiply by the density, 0.997 grams per milliliter, our milliliters cancel out, and we get a mass of 217.346 grams. And I've written more digits here than I need, and that's just to protect me from rounding off prematurely, because I'm going to use this number of grams with the molar mass of water. Water has a molar mass of 18.015 grams per mole, and so using the number of grams, multiply by 1 mole per 18.015 grams. Again, our grams cancel out, and we get that the amount of water is 12.0647 moles, or rounding off to an appropriate number of significant figures, we've got 12.1 moles of water. Now, if we want to find the amount of solute that's dissolved in a solution, things are a little trickier. Let's say, for example, that we had some salt, sodium chloride. This is a solid, and we are dissolving this in water. So when you dissolve a material in another material, the stuff that is dissolving is referred to as the solute, and then the stuff that it's dissolving in this case liquid water, is our solvent. And when the solute and solvent are mixed together, you get a solution. And in this case, we have an aqueous solution of sodium chloride in water, and we could represent that as NaCl aqueous. Now, if we had this sample of sodium chloride dissolved in water, and we wanted to figure out the amount of sodium chloride in the solution, well, we need to know how much solution we've got. And we could determine how much solution there is by weighing it, so we could find the number of grams of solution. Or since this is a liquid, we could find out how much solution there is by measuring the volume. And again, since this is a liquid, it's more common that you would measure how much of it there is by using something like a graduated cylinder and measuring the volume. So if we wanted to find the amount of sodium chloride that is dissolved in a solution, we would like to have some way of relating the volume of the solution with the amount of solute that's dissolved in it. Now, we can describe this qualitatively for example, if there is a lot of solute dissolved in a solution, could describe the solution as being concentrated. If there's a relatively small amount of solute dissolved in a solution, we could say that it's dilute. And what we want is a way to put a number on this concentration. We want a way that we can numerically relate the volume of the solution with the amount of solute. So some way of going from one to the other. Now, the way that we measure volume of solution, there's various ways to do it. The official SI unit for volume is the cubic meter, and this is nice. It's based on the meter, which is the standard unit of length, but it's not usually a convenient way to measure volume. A cubic meter is a pretty large volume, and we don't normally carry around containers that measure cubic meters of samples. Now, another common unit that's used for volume in the metric system is the milliliter. A milliliter is roughly the volume of a large blueberry. So to give you some idea of the volume that we're talking about. And then another common volume that's used, volume unit, is the liter. A liter is 1,000 milliliters, and this is a convenient size of unit for measuring liquids. A typical thermos flask that you might use for carrying water around might have a volume of about a liter. And when people are doing conversions between volume of solution and the amount of solute, liter is the volume unit that they normally work with. Now, our choice of units for the amount of solute is much easier. In the metric system, there's only one unit of amount, and that is the mole. So what we would like is some way of putting a number on the relationship between the volume of a solution in liters and the amount of dissolved solute in moles. And this numerical measure of concentration is used. It's commonly called molarity. The molarity of a solution, which is given the symbol capital M, is the number of moles of solute in 1 liter of solution. Molarity is often also called the molar concentration of a solution, and it's very frequently simply called concentration, although that's you need to be careful with that because there are other ways of describing the concentration of a solution. So molar concentration or molarity is what we want to say when we're describing the number of moles of solute in a liter of solution. So